You asked Tony for viewing the docs locally, and they are at the GitLab. So if you follow the link here, GitLab, you go to the repository of the code of these docs, and here in the directory apps are the instructions that we are following, and they are in Markdown, so it is easy to view them with any editor. For example, Docker intro is this one here, and you can also render the website or create the website locally if you follow the instructions at the README file. So there is a README file here, and you have to install Yarn. I don't remember right now how to install it, but you can search how to install Yarn. And then for local development, you just run yarn start in the directory of, after cloning the repo, in the directory of the repo. And it will it will start a local web server that displays the docs, the documentation. This is, for example, for me, if I want to develop and check how they look. But you can also use it locally if you prefer. Okay, we can continue with the Docker introduction. We will build an OpenSSH container. This is a Docker container that contains an OpenSSH server, so that we can SSH into this container, either from the host or from outside, from the internet. And let's create a directory for building and for managing this container. So we will use this directory to build and manage or maintain this container. And let me also add this option -p. And now we are going to create a Docker file. A Docker file contains some instructions for building a Docker image. So these instructions will build a Docker image. And they have some specific instructions. For example, start from this base image. It is using Debian 13 as a base image. And by the way, this is not a command. This is also a kind of instruction. So you should not miss it, or you should not delete it. It looks like a comment, but it also plays some role, some function. And then after starting from this base image, the next instruction is run this command, apt update, and then apt upgrade. And I am using this option yes, so that the command runs non-interactively. It does not stop to ask yes or no. It just runs without asking. And then I am installing also apt install this package proc.ps, which contains the command ps and maybe some other tools. So we installed it manually last time. We started the container, we started bash inside the container, or we got a shell inside the container, and then we installed this package manually. But now we are running it. We are installing it automatically in this inside this image And then the next instruction contains this block of code. This end of file is a token. It should be the same. It is similar to here document in bash scripting. And here we can run several commands. So with run we can execute just one command. It can be a composed command. This is composed of two commands, or it can be a simple command. But with this form, we can run several commands and or a piece of script, a piece of bash script, and this is more convenient sometimes. And it is also a little bit more efficient because each of these commands create another layer on the Docker image, creates an additional layer. So if we run one by one all these commands with run, they are going to create unnecessary intermediary layers. But this command will just create one layer. And then this instruction workdir /host shows the default working directory inside the container. Also, when we get a shell inside the container, we will be in this directory by default. And the last instruction command shows what command to run inside this Docker container. And the command is the sshd service with the option -d, which I guess means I'm not sure what it means. Anyway, we installed openssh server here with this instruction, and then we created this directory var run sshd, and then with this sed command we modified the sshd configuration file, and we modified the instruction that says permit root login to permit root login prohibit password. So the user root is able to log in to what happened here? Let me share the screen again. There was some interruption, network interruption, I think.
Yeah, probably yes.
Okay, I hope now it is okay. So we can continue. So this command is modifying the configuration file sshd config, so that the instruction permit root login goes like this: permit root login, prohibit password. So a root user is allowed to log in, but not with a password. And we will see later how it will log in. It will use a public-private SSH key. Okay, so how do we build the image from this Docker file? From this Docker file, we run the command docker build. This is the tag of the image, or the name of the image, sshd image, And this is the context, the directory, which is the context for this Docker image. And the context directory is the current directory. And the command docker build is going to look for a file named docker file and will run the instructions inside this file. So let's press enter. So in the previous examples, we downloaded a Docker image from Docker Hub. This image was built by someone else and was uploaded to Docker Hub so that we can download and use it. But this time we are building our own image, starting from a base image. Starting from Debian 13, we run some other instructions and build a custom Docker image. And this is the image that we just built. Because if you remember if we recall the command, this is the name of the image. And can I get help, for example? Here. So this option T is a tag or image identifier or image name, something like this. And if we look, for example, at the history of this image, Docker image history, we see the commands that we executed to build this image, but in the reverse order. This was the first command, the second command, and then the next block, and then these two instructions at the end. Now let's create a Docker container that is based on this image, on this Docker image. But to create the container, again, we will use a bash script, a small bash script that we will copy from here. So we are using the command docker create. Before we use the command docker run. Docker run both creates a Docker image, a Docker container, and starts it. But Docker create just creates a Docker container, and we have to start it manually later. This is the name of the container. This instruction or this option mount is mounting one directory from the host system to a directory inside the container. Mount type bind. The source directory is this one, working directory. This is the current directory, the full path of the current directory, and the destination is the directory /host inside the container. So the current directory is going to be mounted to the directory /host inside the container. Then this option ---- publish, or it can be just -p, the short version of the option, is forwarding this port from the host to the port 22 in the container. And then this other option, restart, unlist, stop. So if the container is running and we restart the host, for example, the VPS, After the VPS is restarted, then the container will start to run again, this container. But if the container is stopped and the server is restarted, after restarting, after the server is restarted, this Docker container will still be stopped. This will define the host name inside the container. And this is the image that will be used for building this container. So let's try this command. Docker ps. We don't see that container running, but if we use the option -a for all, we see this container, which is status is created, but it is not running yet. So let us start it. Docker start sshd. This is the name of the container, sshd. And Docker logs sshd. It is not producing anything, but now we see that this container is running. So this is the container ID. This is the image where the container is based. This is the command that is being executed or that is running inside the container. This is the creation time, about a minute ago. Status up since this many seconds, and then the next is ports. These are the ports that are forwarded to this container. The port 2201 from the host is forwarded to the port 22 on the container. And also this is the IPv6 version. And this is the name of the container. Now, if we have a look inside the container, docker exec, the name of the container is sshd, and we will execute the command bash inside the container. We get a shell inside the container, and we see that the host name is this one, opensshd, because we specified the host name in the command that created this container. And the working directory is this /host, because this was the working directory inside the container. We specified it with this instruction inside the image, that the working directory is /host, the default directory when we log in or when we get a shell inside the container is this. And this specifies the host name of the container. And the command ps is available inside the container because we installed it when we built the image. In the Docker file, there was the command to install the proc ps package. The main process is this one, user sbin sshd. And this is the content of the host directory, but this host directory is mounted to the directory var docker ssh into the host. Now we are going to create another bash script we are going to execute this bash script inside the container. So let's create this bash script named setup key. This command is going to generate an SSH key. The command that generates the SSH key is this one, SSH key again, and the file where the key will be generated is this one, /host/ssh key. This is quiet, this is no password, something like this. But first we are checking that the key does not exist. So this test is checking that the file SSH key exists or not. And if it does not exist, then this command will be executed. And then the public key will be named sshkey.pub, and we are going to append actually to copy the content of this file to the directory .ssh authorized keys, and this is inside the container, because this script will be executed inside the container. And these two commands make sure that this directory .ssh exists and it has the correct permissions. And with this command, we also make sure that the file authorized keys has the correct permissions. And now that we created this script, we are going to copy it inside the container. Docker cp setupkey.sh. This is the name of the container, sshd. And this is the path where the script will be copied. So after this semicolon comes the path. So we are going to copy this script into this temporary directory inside the container. Now let us execute this script inside the container. Docker exec into execute inside the container sshd. First we check the content of the directory temp, and we see that the script that we copied is there. And now let us execute it. So inside this container, we are going to execute this script /tmp/setupkey.ssh. And we see that this script has already created these files. Actually, it created these files inside this directory, /host. But the directory /host inside the container is the same directory as the current directory here, outside the container. So here we have the public key and the private key that were generated. Now let us also execute another script inside the container, which just provides a better prompt and some other improvements. So we have a cut command, and it is going to copy all this content up to the end of file to through the pipe to the command T, and the command T is going to append this content to the file /root/dot bash rc. So it is going to append some instructions to dot bash rc inside the container. And one of these instructions is to change the value of variable ps1, which defines the prompt inside the container. So let us execute it. Docker exec sshd, and I will execute it like this. And it was executed. Now, how does it work? Why I did not copy it inside the container, but it was still executed? I did not copy it. Why was it executed? It was executed because the working directory inside the container is host. And this directory host inside the container is mounted to the current directory outside the container, to this directory outside the container. If I execute, for example, the command, what is the working directory? Print working directory, it is host. And if I execute the command ls, it is going to list the content of the working directory, which is this one. And so we see that I already have this in the working directory inside the container. So I can just execute it like this. Now let me get a shell again inside the container. SSHD, but with these options. And now we see that we have another prompt. So the prompt inside the container has changed, and it has changed because let me use cut. Because of this instruction inside this file .bash rc. Now I have this private key. I can use this private key to SSH into the container because it is an SSH container. It is running SSHD inside it. And I should be able to log in with SSH into this container. SSH, the port is going to be 2201. The identity file is this SSH key. This one. And root at localhost, and I'm inside the container. So I am accessing the account root into the localhost, but using the port 2201, and the port 2201 from the host is being forwarded to the port 22 of the Docker container, and then we are using this private key to to authenticate, so that we don't have to use a password. Now this also works outside the container, so I can use a similar command, except that I am going to change the localhost with something else outside the container. So let me try it from somewhere else, not from the VPS itself. First of all, I have to copy this key outside the container. I'm creating another tab here. And here I'm not on the server, I'm not on the VPS, I'm on my local machine. So I will create this key, vps1.key, for example. Or let me use nano. And I'm going to copy the content of this file. I'm highlighting all these lines, Control Shift and C, copy, and then go to the other tab, Control Shift and V, Control O, Control X, and exit here as well. I have to change the permissions of this file, otherwise SSH will refuse to use it. Oh, now it is okay. And let me use the IP of the VPS. The IP is this one. And I'm going to use the port 2201. Identity file is this one here, vps1.key, and press enter. And I am inside, but not inside the VPS itself. I am inside the Docker container that is running SSH daemon. So this is the IP of the server of the VPS, but I am accessing the port 2201, which is forwarded to the Docker container. Okay, we finished this example. That's about it. Now we'll see how to install WordPress with Docker containers. And in order to install, we will install WordPress 3. And WordPress 4. So we are going to create a Docker container for each of these, for these two websites, for each of the sites. But we also need another, we are going to create another container for mariadb. mariadb. And also we need a virtual network, a Docker network between these three containers, so that they can communicate with each other. So that this container can communicate with mariadb, and this one can communicate with mariadb. So we are going to create a Docker network as well for these three containers. And because we have these two sites, we also need a reverse proxy. But this time we are going to use the Nginx that we are using for other websites as a reverse proxy. So we can also containerize Nginx as well. We can install Nginx inside a container. But just to keep it simple for this example, we will use the Nginx that is running on the host, on the server, as a reverse proxy. So let's start with the Docker network. This command, ls, is listing the available networks. And if we see, for example, we see this interface Docker 0, which is actually a Docker network. But we are going to create another one for this example. So let's use the command docker network create, and we will call it vpnet, WordPress net. And let us list the networks again. We see this network here that was added, was appended to the list. And we can look at some details with inspect. So we see, for example, that it is using this subnet and this gateway. Now let's create a mariadb container. We are going to use an image from the Docker Hub. So this is a list of some containers in Docker Hub that are named mariadb, or that contain mariadb in their name. But we see that the first one is an official one, so we are going to use this one. And the other Docker container, Docker images have some prefix. For example, mariadb max scale, or for example, bitnami mariadb, etc. So this container, this image was created by the username or the organization name bitnami. But this one does not have a prefix or an organization name or a username because it is an official image. So we are going to use this one. Official images in Docker Hub are images that are maintained by for example, this is maintained by the MariaDB Foundation, so it is better to use this image. Docker pull MariaDB. It is here, and we can have a look at the history of the image. here we see, for example, the version that was used or that was installed, and this volume is a shared directory. So this directory is shared with a directory on the host, so that the databases or the data of MariaDB are stored on the host, so that if we rebuild the container, the data are reused. The data of the previous container are reused. This is the port that is exposed. The port is 3306. This is the command that is running inside the container, mariadb daemon or daemon. And now let's create another directory like this one for the container MariaDB that we are going to start. Now, why do we use a separate directory for each container? Because we have maybe to use a Docker file, or maybe we have to create several bash scripts that are related to this container. It is better to save all these things in their own directory, the things that are related to one container in one directory. This is a better organization. So we are doing this. We are creating a separate directory for each container, not because it is required by Docker, but just to organize better our stuff and our scripts and so on. I will call it db1. And now let me create a script that will create the container. So first of all, we are creating this directory data inside the current directory, and then the command docker create is going to create a Docker container. The name of the container, db1, the host name inside the container will be mariadb, the network to which this container will be connected will be VPNet. If we don't specify a network, then it will be Docker 0, the default Docker network. And network alias, this is how this container can be reached inside this network. So from another container, if I ping mariadb1, then it will ping to this to the IP of this container. So from if I want to access, for example, MariaDB to access this database from the WordPress container, then I can use this name. Actually, I can also use this name, the name of the container, and it will ping to this container, to the IP of this container, and then the option mount. Again, I'm mounting the directory data inside the current working directory to the directory var lib mysql inside the container, and the directory var lib mysql are where the databases of MariaDB are stored. So the databases and the data actually will be stored outside the container itself, in a directory that is outside the container. So if I have to rebuild this container later for some reason, the data will persist. the databases and the data inside these databases will not be destroyed, but will persist, will be persistent. And we have seen this, restart and restop. And this option is defining an environment variable inside the Docker container. And this actually is required by this container. So if we go, for example, to Docker Hub, if we go to Docker Hub and if we search for mariadb, for example, container, this is the page of the image that we downloaded. And if we look at the instructions, there are some instructions here how to use this image. Then we see that this is one of the instructions that is suggested for using this image. So we are defining this mariadb allow empty root password equal to 1. And then this is the image, the name of the image. Undo. Okay, let me just delete it. Create the container and docker psa. This container is created but not started yet. Let's start it. And now it is running. If we have a look at the logs, these are the logs of the mariadb server that is running inside the container. And it says ready for connections. So it is up and running. Now, we see that this data directory was created from the script, and it was also mounted inside the container. And actually, we see here the content of the directory var libmysql. So this is the directory inside the container, but this directory is mounted to the directory data outside the container. Now, if we want to give some commands to mariadb, we have to get a shell inside the database. And we usually get a shell by running the command mariadb. But we have to run this command inside the container. So let's do docker exec. We are running this command mariadb inside the container db1. And we get the database prompt here. Now let's install the the container for the WordPress 1 site, for the WordPress 3, for the site WordPress 3. Let's create another directory for this container. And this site will require a database and a user and a database user. So let's create this database and this user before starting the container, before creating and starting the container. And we know how to access the mariadb shell. We can run the command mariadb inside the container db1. So let's start the shell again, and let's create the database. Create database. WordPress 3 DB. And it is created here. And now let's create a database user. Create user. WordPress 3 user. Add. This is a wildcard. This is a wildcard that says any host. So we don't mind where the connection is coming from. It will be accepted. Identified. And the password is WordPress 3 pass. Semicolon. Select user host from mysql.user. Just to verify that we have created the user, and we also have to grant some permissions to this user. Grant all on WordPress 3 DB .star, which means any table on this database, to WordPress 3 user show grants for WordPress 3 user. Let me type it again. Show and we see that it already has the permissions. Flash privileges and exit. So we prepared the database and the user for the new site. Now we need to create a WordPress container, and we are going to download an image for this container. We see that there are many images, but this one, the first one, is an official image, so we better use this one. Docker pull WordPress. So inside this image, PHP is installed, and WordPress application files are installed, and also I think Apache 2 or Nginx. Docker image. It is here. Docker we see that Apache 2 is installed inside this container, and the command that is running inside the container is Apache 2. And this directory is supposed to be shared with the host. And we also see that PHP is installed as well inside the container. So everything to run the WordPress site, except the database. The database should be external to this image. Now let's create a container for, let's create a script that will start this container. So this script is creating this directory www, and then the command docker create is creating a container, the name of the container WordPress 3, the host name WordPress 3, the network to which this container will be connected is WordPress net, and the port that is published, it is publishing the port 8083, and the port 8083 is forwarded to the port 80 inside the container, but only if it is accessed from the local host. So this port cannot be accessed from the internet. If it is accessed from the local host, then it is okay. If it is accessed from the internet, it is unreachable. And actually, this will not be accessed from the internet. It will be accessed by, from the reverse proxy, and the reverse proxy is in the local host. So that's why we are restricting the access only to the local host. And the directory www is mounted to /var/www/html inside the container. And here there are some environment variables that contain the settings for accessing the database host mariadb1. This mariadb1 was the alias that we specified for the MariaDB container. And now from inside this WordPress container, when we try to access MariaDB1, actually it will access the IP of the MariaDB container. The name of the database, DB name, DB user, DB password, and this is the image name, WordPress. So let's create this container. Docker all. It is created. Let us start it. Docker start WordPress 3. Now it is running, and this is the port that is forwarded, 8083 to port 80. And let us look at the logs. So first of all, it is checking for WordPress files. It says not found, and it is copying them. Copy complete. WordPress has been successfully copied to var www.html. No WordPress config.php found. And because it does not find it, it is copying this file to this one. And I think that Apache 2 is running. So we see that it has already created this directory. And inside this directory is the content of the WordPress files, WordPress application. Now, let's see whether we can access the port 8083 from the local host. And we are going to use a command line browser. We can use this is a browser that can be run from the terminal, can be used from the terminal. We will try to access this site. And we see that we are seeing something. So it is working. Press Q and then Y. So this is now working, but if we try to access this port from outside, from the internet, we will not be able, because this port is closed on the firewall. Instead, we should set up the reverse proxy, so that the reverse proxy is then forwarding the request, will be forwarding the request to this address. So let's go to the configuration of Nginx that we are using as a reverse proxy. And let me copy this configuration. And now I'm going to replace WP2 with WP3. And I can do it with this command, control and backslash. Replace this one with this one. Yes. And let's look at the proxy path here. The command proxy path here, I'm going to change this to and then port 8083, because this is where we can access this WordPress site. So let me save and then exit. Sites enabled. So I created this symbolic link. And check the configuration of nginx. And we see that the certificate does not exist. Cannot load certificate. So we did not receive an SSL certificate yet for this website. So let us receive an SSL certificate as well. Certbot, cert only, webroot, domain, wordpress3.user1.fs.al, and also for the domain www.wordpress3.user1.fs.al. And let me try first with dry run. The dry run was successful, so let me remove this and instead add the mail account. And also agree to terms of service. Now it seems that it worked, and we can check with certbot certificates. And it is going to list all the certificates and this one as well. So the certificate is there. Nginx test the configuration. Now syntax is okay. System control reload nginx to activate the configuration of this WordPress 3 website. And the final step is to open it in browser. And we start the installation wizard. Site title, WordPress 3. Username. This is the database username. And no, this is not the database username. Admin. Let me keep this password. It's a strong one. Your mail. First time when we installed WordPress before, it was asking for the database settings as well. But this time it did not ask for the database settings. Why? Because we have specified them here. When we created the database, when we created the container, we also specified these environment variables. And as long as the container notices these environment variables, it makes the configuration according to them, the configuration of the database according to these variables. And so it does not have to ask in the wizard about the database name, database user, etc.